And so this is question 8 from your homework form a couple of nights ago. It says, determine the average velocity for the entire trip. So this trip took 14 seconds and it was 400 meters altogether. Now I think this graph might be a little bit wrong. I think it's actually a total displacement of 400 meters. And so I'm going to try 400 and I'm going to divide it by 14 and I get 28.57 and the answer is 29. So that's pretty close. So I've just gone from the initial position of 0 meters displacement to 400 meters. So I'm ignoring this little nub here. Determine the average velocity for the last 10 seconds of motion. Okay. Now, the last 10 seconds of motion appear to be uh, 4 to 14. So that's about 40 meters to 400 meters. In other words, 360 meters of displacement, and that's in 10 seconds. And so that's about 36 meters per second on average. Why are the two velocities different? It's because there is acceleration involved, and so the last portion is going to be faster than the first portion because the velocity, the initial velocity, has increased. Determine the instantaneous velocity at 4 seconds and 8 seconds and 10 seconds. Okay, so this is the not so simple problem because basically we want to know the slope of the line, but the slope of the line is constantly changing, and so we have to use tangents to try and determine this. And so here it is at 4 seconds. I need to figure out what that slope is. And so I don't know. There's the approximate slope there. Okay. So it looks like, I don't know. At 4 seconds, roughly that is 100 divided by, there's a rise of 100 for a run of 7. So whatever 100 divided by 7 is, 10, 15, 15.8. So the velocity at 4 seconds, using the tangent, is about 15.8 meters per second. I'm just guessing. Now at 8, oh, he's going faster, whoever it is, he or she. And so here is the tangent at 8 seconds. Now I'm going to put it up here and try and find a nice slope. And so I see that, oh, that is very close to about, I can extend this and still keep the same slope approximately. In 6 seconds, this person goes 200 meters. So 200 divided by 6, that is roughly 33. It's about 33 meters a second at 8. And then, oops. And then at 12, I'm going to adjust my tangent again, and I'm going to make it a tangent there. Oh, that's tough. Okay. This is all by guess and by gosh. So I imagine, if you did this, you might go a little bit cross-eyed trying to get it. And so here's the slope at 12 seconds. It's about the same as 300 divided by 6. And so it looks like it's about 50 meters per second instantaneous velocity. Sketch a qualitative velocity time graph for the motion of the car. And you can't see that right now, but that's what the last part is there. Okay, now this car is increasing in velocity, and so this is going to be, the velocity time graph is going to have a positive slope because velocity is increasing. My guess is this is a quadratic relationship, and so velocity will be increasing. It will be increasing linearly. And so just to draw a qualitative sketch, the axes are wrong here, but it's going to be a linear increasing slope.